This poster is about circular motion and centrifugal forces. Centripetal forces. In the top left-hand corner, it says a body moving in a circular arc is accelerating and follows Newton's first law. This suggests that Newton's first law is acting in centrifugal forces. There's a force acting towards the centre of the circle, which is the acceleration. As seen in the left-hand top right-hand corner is a diagram of a circle, where the velocity is coming straight off the tangent of the circle, which is perpendicular to the velocity going inwards. Inwards towards the centre of the circle. There's this force called acceleration. Now back to the left-hand side. This causes the body to deviate from the straight line, which is, you can see by the velocity, which is which it would naturally follow if the force was absent. One example of this could be the sun orbiting the earth orbiting the sun, or a ball swung around in a circle, or even a electron orbiting a proton. Well, the example I got here is a ball swung around in a circle. If a ball is swung around fast, or the faster you go, the more the centrifugal force in the circular motion, the larger the force, or the larger the force on the string. And if the force is greater than the tension, then the string can break or snap, and the ball will continue to travel in the straight line along the tangent of the circle. Below this, we got radians. Well, the thing you got to remember is arc length equals S, which equals R times theta, where 2 pi, which can be denoted, radians can be denoted by a C or rad. 2 pi equals 360 degrees, and half of that is pi, which is 180, and half that again, which is pi over 2. If you ever want to find out, or you're unsure, just remember pi is 180. So say the angle is 29 degrees. Just do 29 divided by 180 will give you, make sure you calculate it in radians. Just go to mode, and I think it's settings 3, or shift mode settings 3, and then go whatever your angle is in degrees divided by 180 will give you your answer in pi. So if you go in the middle, angular velocity, angular speed, W, is the radians per second complete for one complete rotation, or the circumference, which is 2 pi r. Therefore, the equation of one rotation equals V equals the circumference times r over t, which equals V equals rw. Or you could say, if you put it in that format, W equals 2 pi r, or theta, over t. Deriving V equals Rw by the arc length. If an object travels the distance s in the time t along a circular path, therefore V equals its displacement over time, hence V equals r theta over t. Because theta over t is the angle per second, which is the radius the line turns through, then theta over t is the angular speed w, so therefore V equals Rw. Remember the frequency, you should know this, and the period. It's exactly the same the waves you did in PH1. Frequency is the number of rotations per second, which is measured in hertz, and the period is the time taken, is the time for one complete rotation. This is measured in seconds, so you can remember this by frequency is 1 over time. And then below this, we got all the equations you need to remember, plus the ones that got green hashed. Where these hashes are, which is the title is moving in vertical circles, which can be seen in the diagram below. When the object is at the top of the circle, in vertical, this is now not horizontal, in vertical, the weight is acting downwards, so is the reaction force, which is acting towards the centre. On the side, the weight is acting down, always acts down, and then the reaction always acts inwards, so it's acting towards the centre, and the same for the bottom. If you look at the equations, at the bottom, RB is take away the mg, and at the top is RT plus the mg, which equals mv squared over r. Thank you for listening.